Let me pause this. This is just a list of people pointing to the person next to them. But this is no ordinary list. It has a few rules. We will call these people nodes, like this is a node. These nodes are facing in this direction and they are pointing to the node next to them. Except for the last node, it's pointing to no one, that is null. So, these people know who is next to them, but they don't know who is previous to them. For example, this is A and this is B. A can see that B is next to him. So A knows that A dot next is equals to B, and B knows that nothing is next to him, so he knows that B dot next is equals to null. But neither A or B knows that who is standing previous to them. The other rule is, these people are unaware of their position in this list, that is, they don't have an index. Except for these two. The first node knows that it's a head, and the last node knows that it's a tail. So in conclusion, this is a node, and a linked list is a list of such nodes pointing to the next node. And in a null terminated list, the last node is pointing to null. The first node is a head, the last node is a tail, and it's unindexed. What happened? Feel lost? You didn't like my analogy? Let's try again. Differently this time. This is our trusty ABCD array, and the way that a linked list is different from an array is that it doesn't have index. So let's remove them. Let's space these items around. Each item is pointing to the item next to it, but no item knows what's previous to it. The last item points to null. The first item is head, and the last item is tail. These items are called nodes in linked list. So finally, our ABCD array looks like a ABCD linked list. Okay, now suppose this is our memory. Array is stored in contiguous places of memory. Meanwhile, each node of a linked list is stored in a random place in memory. This is a node, and this is what it looks like as a code. This node has a value of f and it's pointing to null. Now see this linked list. Let's see what this linked list looks like in terms of code. So our first node has a value of a and b is next to it and it points to b. So how do we point this to b in code? We just say next is equals to b node. Similarly, b has a value of b and its next is c and c's next is d. JavaScript does not have a built-in linked list. So let's build it from scratch. A node is nothing but a class. If you don't know what a class in JavaScript is, I think you should pause this video and search what is a class in JavaScript. So this is what our class node should look like. It should have a value and it should have a next. Let's create a constructor function for this class. Okay, this is what we want our constructor function to do. We give it a value of f and it returns a node with a value of f and it points to null. This is a class of node and the constructor inputs a value. This dot value is equals to the value which we just input, and this dot next is equals to null as this points to null. Okay, now that we have made a node, let's make our linked list. Class linked list. It has a constructor which inputs a value. Now we will use the node class we just created to create a new node. Const new node, which is equals to new node which takes a value. And as you remember, this spits out a node with the input value and next is equals to null. Okay, do you remember that our linked list has a head and a tail? As right now there is only one node in this linked list, we will set this dot head is equals to new node and this dot tail is equals to new node. Let's also set this dot length is equals to 1. We have just created the constructor for our linked list. It will return a linked list with one node, that is the new node, which is pointing to null, and the head and the tail is pointing to the new node.